Hi there, Mr. Sutton bringing you the AB Calculus 612 homework solutions on area between curves. For this no calculator problem, we want to find the area of the region enclosed by y equals x and y equals x squared minus 3x plus 3. So we have a line and a parabola. We know those are going to intersect at most two places. Let's go ahead and find the intersection points, and then those will also give us our limits of integration. So we're going to have to solve a system to get these intersection points. I'm going to set x equal to this parabola over here. And then let's go ahead and subtract x from both sides. So this is going to be x squared minus 4x plus 3. I can factor this into x minus 1 and x minus 3. That gives me x values of 1 and 3. So these are going to be my limits of integration. Now, I'm not really sure which way this is going, whether the line's on top of the parabola or vice versa over this interval. Probably the line's on top because this parabola is opening up. But just to be on the safe side, I'm going to use absolute value. So I'll do integral from 1 to 3 inside an absolute value here. And what's my integrand going to be? Well, it's going to just be one function minus the other, and I don't really care about which way this goes because I'm using this absolute value to make sure things come out positive. But now if I want to do one function minus the other, well, that's essentially what I did to zero out this equation right here. I did this function minus this other function on the other side. So I'm just going to put x squared minus 4x plus 3 dx inside there. Now I'm going to go ahead and take my antiderivative. So that's going to be 1/2 x cubed, or actually 1/3 x cubed minus 2x squared plus 3x. Integrating that, or evaluating that rather, from 1 to 3. So that's all this stuff with 3 plugged in, which we're going to have to figure out in a minute, minus all this stuff with 1 plugged in. Okay, so all this stuff with 3 plugged in, what do we have? So this is 1/3 of 27, which is 9. We're subtracting 18, so that's negative 9. But now we're adding 9, so that's 0 for all this stuff here. And then for this next one, this is going to be 1/3 minus 2 plus 3. Well, minus 2 plus 3, that's going to be a total of 1 over there. So this is 1/3 plus 1, and we're subtracting it. So this all comes out to negative 4/3. And absolute value of all that's just going to be positive 4/3, which gives us choice C. For this calculator-based problem, we're told that R is the region enclosed by this y equals 1 plus ln graph, the x-axis, and the lines negative and positive 2/3. We just want an integer approximation of the area of R. All right, well, let me put this in Desmos since this is a calculator problem. And when I do that, I'm just going to call this f of x just in case I need to use the function elsewhere in the problem. So we have 1 plus ln, and in here, so unfortunately Desmos does not support like putting this exponent 4 next to cosine. It works with 2 and negative 1, but not anything higher than 2. So I'm going to actually put a parentheses with just cosine of x in it, and I'm going to raise that to the 4th power, and that's how I'm going to do cosine 4 of x. All right, so here is what that graph looks like. And we also have the lines x equals 2/3 and x equals negative 2/3. So we're just trying to figure out in this region right here between this and the x-axis, what's our area. So what I'm going to end up doing here is just taking the integral then from negative 2/3 to positive 2/3 of this ln function here. I'm just going to put this whole thing in, and I don't really need to, but just to be on the safe side, I'm going to put that in an absolute value, just so there's no question about this giving me a positive area. So going back here, let me just do integral, and then we have negative 2/3 to positive 2/3, and in here I already did my f of x function, so I'm just going to do absolute value of f of x function, and again the absolute value is probably not necessary here, but whatever, and then dx comes out to about 0.919. They wanted the nearest integer, so that's approximately 1, which gives us choice B. On this problem, I want to find the area enclosed by x squared and x, and no calculator for this problem. So let's start by finding where these two things intersect, and that'll tell us the limits of our enclosed area. So we have x squared equals x, solving a system of equations here. And if I subtract x from both sides, and then factor out an x, that's going to give me, let's see here, 0 and 1 for my limits of integration. And I'm also going to use absolute value when I integrate this because I'm not really sure which one is the top function versus bottom. I'm guessing x is the top function because this parabola opens up. But let's just be on the safe side. We're going to do integral from 0 to 1 inside an absolute value. And for the stuff inside here, my integrand, well, I'm just doing one function minus another, so x squared minus x dx. Taking my antiderivative, that's 1/3 x to the third minus 1/2 x squared, evaluated from 0 to 1. And let's see, that's all this with 1 plugged in, minus all of this with 0 plugged in. So over here I've got 1/3 minus 1/2. Over here all this stuff is just 0. So we have 2/6 minus 3/6, that's negative 1/6. Absolute value of that is positive 1/6, giving us answer choice A. For this calculator-based problem, they want the area of the region between x squared and negative x, between 0 and 2 for the x values. So let me just give each of these a name. I'll call x squared f of x, and I'll call negative x, I'll call that g of x. And let's go ahead and graph these. I mean, I pretty much know what they look like. These are basic functions, but hey, we've got the graphing calculator. Let's use it, right? So there's x squared, and here is g of x. That was negative x. And we see that between 0 and 2, x squared is going to be higher. So when we take this integral, we're going to be doing f of x minus g of x. So to do our integral then, we're going from 0 to 2, f of x minus g of x dx, and we'll just plug that right into Desmos the way it is. So int integral 0 to 2 parentheses f of x minus g of x, close the parentheses, dx. And our answer choices are all fractions, so I can just press a quick button here. This little button right here turns my answer into a fraction. So that's 14/3, which matches choice D. On this problem, I want the area of the region in the first quadrant enclosed by these two graphs. So because I can't use a calculator on this, I can't graph it out, so I need to figure out manually what my intersection points are between these two functions. That's going to give me my limits of integration to find my area. So let me set these equal. X cubed plus 8 equals x plus 8, just basically solving a system to find my x values where these things match up. And I'm just going to subtract x plus 8 from both sides. The 8's are going to cancel, so I just have x cubed minus x equals 0. Factoring out an x, that's x squared minus 1 inside. So then I have x-intercepts of 0 for that x out there. And for this inner one, I can just add 1 and square root, so that gives me plus or minus 1, initially at least. But now going back to the problem, they said they want first quadrant. So that means I don't really care about this negative 1 right here. I just care about the interval from 0 to positive 1. So that's what I'll use for my limits of integration. And because I don't know which of these two functions is the top function, I'm going to use an absolute value around my integral just to make sure I get a positive answer. So I'm going to have then the area equals absolute value of the integral from 0 to 1. And I'll just spell it out that this is area I'm finding. And now for my integrand, I'm going to do basically one of these functions minus the other function. And again, I don't care which order I do this in because I have the absolute value out here to kind of protect me from negative answers. So I'll just do first minus second. Now, it turns out we already did that subtraction here when we moved x plus 8 over to the left side of the equation. So this x cubed minus x is really one function minus the other. Just stick a dx next to it, close the absolute value out, and we've got our integral. I am going to have to do all this by hand, though. Again, this was a no calculator question. So my antiderivative, this is going to be 1/4 x to the fourth for that first piece, minus, bump this up to a 2, so that's 1/2 x squared. Evaluate that from 0 to 1. 0 and 1, I mean, you could have worse numbers to work with, right? I mean, we've got all this stuff with 1 plugged in, which is going to be pretty easy to do, except for the fractions, minus all this stuff with 0 plugged in, and we really can't argue with that. So this whole second piece here is just 0. This first piece is really all that's going to matter then. This will be 1/4 minus 1/2, and that's negative 1/4. It's really 2/4, or actually 1/4 minus 2/4. But absolute value of negative 1/4 is just positive 1/4, and that ends up giving us answer choice A. For this problem, the region bounded by the x-axis and part of the graph of cosine of x between negative pi over 2 and pi over 2 is separated into two regions by this vertical line x equals k. They're telling us the area of the first region from negative pi over 2 to k is 3 times the area of the next region from k to pi over 2. We want to know what k value makes this happen. So we're basically trying to figure out where to put our vertical line so that the first area is 3 times the second area. So I'm going to set this up by using some integrals to start off with here. And this is a no calculator problem, but in general when I'm doing this, it's just worth noting that cosine is positive from negative pi over 2 to pi over 2, because that's essentially the x values on the right half of the unit circle, so those are all positive. This means I don't have to worry about absolute value, so I can just set up my integrals without worrying about getting negative area. This is good. My first region then I can express as the integral from negative pi over 2 to k, because I'm going from this negative pi over 2 to this vertical line that they want us to draw, of cosine of x dx. So this is my first integral. Now they're telling me this area is 3 times the next integral. So that's going to be 3 times the integral from k to pi over 2. That's this next area here. And that's still going to be cosine of x dx. It's the same function, it's just a different region of that function. Okay, so let me go ahead and expand all these now and solve for this x value. So using my fundamental theorem, first off, my antiderivative here is going to be sine of x, evaluated from negative pi over 2 to k. And over here, I'm just going to have 3 times sine of x from k to pi over 2. So on the left side, using my fundamental theorem, I have sine of k minus sine of negative pi over 2. All that's going to equal, and I can just multiply 3 by both of these things, so 3 times sine of pi over 2 minus 3 sine of k. Now normally I would have a 3 and I'd have the sine of pi over 2 and k in a parentheses, but I know I'm trying to solve for k, so I know I'm probably going to have to distribute this 3 anyway, so I just did it right away. Let's clean this up a little bit and then we'll solve for k. So this sine of negative pi over 2, that's really negative 1, but we're subtracting that. So this is sine of k plus 1. And then on the right side, sine of pi over 2 is just 1, so this is 3 minus 3 sine of k. Now I'm going to get the sine of k's together and the constants together. So this is going to be, we're going to have 4 sine of k on one side, and let's see, 3 minus 1 is 2 on the other side. Dividing both sides by 4, I have sine of k equals 1/2. And we know there's lots of places where the sine of an angle is 1/2, but we're just looking for an answer between negative pi over 2 and pi over 2. So where, let's see, what sine of what angle would give me 1/2? Well, that would be 30 degrees, or pi over 6. So k is going to be pi over 6. And again, there's other places where that happens, but we're only interested on this interval from negative pi over 2 to pi over 2. And we have an answer choice that matches that. That would be choice C. So we're going to go with that. For this problem, they want the area of the region enclosed by 1 over x minus 1, the x-axis, and the lines 3 and 4. So I'm going to need an integral from 3 to 4 of this function here. And the question is, am I going to need some absolute value? I don't have a calculator to use on this problem, so I'm going to have to figure this out beforehand. Well, this graph is positive if you plug in x values between 3 and 4. It's just 1 over positive numbers in that case.
So that means, since I'm positive in that region, I'm not going to need any absolute value on my area. And it also means when I take my antiderivative of this, I'm actually not going to even need an absolute value when I do my ln. So let's go ahead now and set up my integral. I'm going to have integral from 3 to 4 of this function right here. And this is going to be, let's see, ln. Normally it would be ln of absolute value of x minus 1. But again, I know that I'm only going to get positive numbers that I'm plugging into ln when I do this. So I can just write ln of parentheses x minus 1 evaluated from 3 to 4. I could leave the absolute value, but it's not going to be needed later on anyway. So now plugging both these numbers in, I've got the ln of 4 minus 3, or 4 minus 1 rather, which is just ln of 3, minus ln of 3 minus 1, so ln of 2. And then, let's see, that doesn't look like any of the answer choices, so I'm going to have to combine these using log rules. When we subtract logarithms, we're really dividing the things inside to merge it into one big log. So I can write this as just ln of 3 divided by 2. That matches answer choice D. For this problem, we've got the curves y equals f of x and g of x shown in this figure here. So they were nice and just gave us a picture. And let's see, they tell us these intersect at the point a comma b, and the area of the shaded region in these curves is, and the line x equals -1 is given by which of these answer choices? So we want to find the area of this shaded region. Well, we know for that we're going to need an integral. Even if you didn't know that, all the answer choices have integrals, so yes, we need one. That means we need limits of integration, and we also need to know the integrand. So for the integrand piece, if you're finding area, most of these answer choices don't have an absolute value in them to kind of bail you out if you subtract in the wrong order. So that means we're going to want to do top minus bottom, just so we can at least recognize the answer if it doesn't have an absolute value in it. So the top function is f of x, the bottom function is g of x, so we want to do f of x minus g of x for our integrand. Those are the distance strips that we want to add up that give us positive area. All right, how about the limits of integration? So from left to right, we start at -1 and we're going to the x value a over here. So those are our limits of integration. So then we can write that our area is going to be the integral from -1 to a of f of x minus g of x dx. And does that match any of the answer choices? That looks like it's going to be answer choice D.